Hello, everyone. Welcome back to week 4 of Physical Science RPS at Home. Again, my name is Mrs. McPhillips, and I teach physical science at Albert Hill Middle School. I'm back with you today to continue on our Wednesday daily lesson about electricity. On Monday, you did some exploration with electricity by viewing 3 videos, one about lightning, well, actually 2 about lightning, and then one about triboluminescence, the phenomenon where when you strike 2 rocks against each other, it produces almost something that looks like lightning, like some kind of electric discharge. You also did a PhET simulation that simulated rubbing balloons against a sweater and then seeing, what happens and how they behave. And then I hope that many of you did our optional hands-on activity, electric cornstarch. Today, I will be providing some more explanation for why you saw the things that you observed on Monday. The way that we'll do that is first we will watch a brain pop video that is about static electricity. Then there is a pear deck, which if you haven't used before, is basically like a PowerPoint or a slides presentation that is interactive. And during that pear deck, we will ask and answer several questions. I have open on my screen here the instructions for Physical Science Week 4. I want to remind you that in order to access this, I'm going to show you on my screen. You go to rvaschools.net, the Richmond Public Schools homepage. You click on RPS at Home right here. Then you click Middle School and 8th grade. And your lesson for week 4 on Wednesday will be April 29th. When you click on that, you will be able to access among the other things. You'll have your ELA, your math, I believe it's PE, and then you'll have science on Wednesday. And the learning plan is right here. So these are all the things we did on Monday. And on Wednesday, step 1 is to open up your student workbook. When you click on this link, it will send you right to your student workbook. Please make sure, and it looks like this. This is the same document we were using on Monday. So you should have used this page right here for the writing about the videos, and then this page right here for the questions about the PhET simulation. Today will be on day 2. So here's our brain pop information. One thing to make sure you do, if you would like to type into this document to write your answers down, you have to go to File and then Make a Copy. Once you do that, you can insert your name, like I could do Mrs. McPhillips, Week 4 Science, and then click OK, and it will be saved in your drive. If you don't make a copy, you won't be able to type into it and save it as your own. So with that, let's get started. The brain pop video is for static electricity. Please notice that the link is there and the username and password is also right here. So let's go to brain pop, and I will type in my username was Richmond Public Schools _1. Password is for me to use. Click log in. And it looks like it didn't take me straight to static electricity, so I will type in the search bar, static electricity. And before we start the video, it's this one that has a little sock on it. I do want to make sure that we know what vocabulary words we are looking for in the video. So when you go back to your student workbook, you'll see that there are 6 vocabulary words that will pop up in the video. Electrons, electric charge, current electricity, static electricity, insulators, and conductors. So make sure that you are looking out, especially for those 6 words. I'll play the video with you now, but then on your own time, if you have trouble getting those definitions, go back to the brain pop by clicking on the link here, and you can watch it on your own as many times as you like. But let's watch it together now.
Ow, why'd you do that? Oh, thanks, I guess. Dear Tim and Moby, why do I sometimes get zapped when I touch a doorknob? From Sarah. That's an example of static electricity. Electricity is when electrons, the negatively charged particles in an atom, move from one place to another. In current electricity, the kind we use for power, there's a steady flow of electrons along a circuit. In static electricity, like lightning and those pesky doorknob shocks, there's usually a single sudden transfer of electrons from one place to another. In order for that transfer to happen, you have to have a buildup of electrons on a surface. Hey, what are you doing? Right now, Moby's building up an electric charge. The rubbing makes the balloon pick up electrons from my hair, giving it a negative charge. Because my hair loses those negatively charged electrons, it gets a positive charge. And the negatively charged balloon attracts the positively charged hairs on my head. Because opposites attract, right? I think it looked better before. Anyway, all the matter in the universe is made up of atoms. And every atom contains a certain number of protons, neutrons, and electrons. Protons have a positive charge, and electrons have a negative charge. Neutrons don't have any charge at all. So, when an atom contains the same number of protons and electrons, it has no overall charge, and it's considered neutral. Protons and neutrons are stuck in the nucleus of the atom. But electrons orbit the nucleus, kind of like the moon orbits the Earth. And electrons like to move around. In fact, if you rub two non-conductive materials against one another, those electrons can jump from one material to the other. What are non-conductive materials? Well, conductors are materials that electrons flow through easily. Metals are good conductors. Non-conductive materials, or insulators, don't allow electrons to flow through them. They include things like cloth, rubber, and plastic. Some insulators like to give up electrons, and some of them like to collect electrons. Most carpets are made of nylon and wool. Those substances tend to give away their electrons, leaving them positively charged. Your shoes, on the other hand, have rubber soles, and rubber is a material that naturally collects electrons. Remember how the rubber balloon pulled electrons away from my hair? Well, your rubber soles can pull electrons away from the carpet. All you have to do is walk across it, and the electrons will be pulled out of the carpet and onto the soles of your shoes. A force called adhesion is responsible for the transfer of electrons. You can build up a bigger electric charge by rubbing your feet against the floor. The more you do it, the more electrons your shoes will collect. Anyway, those electrons that your shoes pull away from the carpet stay stuck to the surface of your body. And if you touch a conductor, like a metal doorknob, the electrons will flow out from your body and into that conductor. And they'll do it really, really fast. The shock you feel when you touch a doorknob is millions of electrons flowing between you and the knob in like a split second. That's a lot of energy to transfer in a really short time, which is why shocks can be painful. So, if your home has carpeting, be careful when you're wearing shoes indoors. Right, Moby? Moby? Well, at least no one can see my hair now.
All right. And that was our video on static electricity, thanks to Tim and Moby. You did have all of those vocabulary words plus some more popped up in the video. So please take a moment now to write down the definition of each of these words. You'll see there's a space for the definition, and then there's also a place for you to use the word in a sentence or draw a picture of that word. So I want you to use whatever resources you have, and even whatever language you have, to write the word in a sentence and draw a picture. So please do that. And then when you are ready to move on, we will move on to the pair deck. Now you will go to the pair deck on electricity and circuits. Note that there are two options for accessing the pair deck. The first is to go to joinpd.com and type in the code FLMWF, or you could go to the longer link that's posted under number 2. I'm going to do the first. I'm going to go to joinpd.com and use my code FLMWF. Once you enter that code, it will prompt you to tell the platform how you're feeling, which is optional, but I'm feeling pretty good. And at that point, it might even prompt you to type in your first name. At this point, you can actually move through the presentation at your own pace. So you'll see at the bottom there are left and right arrows. I will go to the right arrow, and you can see our first question to answer was, what are some examples of electricity in your life? I've given you photographs and examples of several here. That's the first question that is in your student notebook. So if you go back to your workbook, you'll see here that our first question is, what are some examples of electricity in your life? Assuming you've made a copy of this, you can then go to the blank box to the right and begin typing some things like batteries are an example, or lightning, etc. You can also just use pictures if you prefer. Then the next question is, what is the scientific definition of electricity? Here I've given you the scientific definition and also a picture that goes along with the definition. That is the second question in your notebook. You'll also notice in the notebook that there are some blue highlighted areas. Those are where you need to essentially fill in the blanks. So I've done a little bit of the typing for you here, especially for the scientific definitions. And wherever it is blue is where you need to type in a word. I would like for you to continue working through the Pear Deck at your own pace. All of the answers to the questions are in the Pear Deck. You will also notice that there are some simulations that are inside of the Pear Deck. So this next one is the same PhET simulation about balloons and static electricity that you should have done on Monday, but I do have some different questions for you to answer. We continue through the presentation and you will see the answers to all the questions. And eventually you get to the second simulation, which is one of my favorites. It is all about building circuits. Whenever you get to this slide, I would like for you to start off with the intro tab, not the lab. And you will see that you've got a lot of different components to build a circuit. I want you to experiment with all of them, but your only goal is to build a circuit that makes the light bulb light up. So obviously right now it's not lit up. I just need you to build a circuit that makes the light bulb light up. Once you've done that, play around with other things. See how many light bulbs is it possible to light up at once. You can click and drag many more light bulbs out of there. See what happens when you connect too many light bulbs or when you connect too many batteries. Try to figure out what happens when you put in a resistor. That might be something you haven't heard of before. So see if you can figure out what it does by playing with it. You can try putting in a switch. You can put in a fuse. Many of you have heard of fuses before, like the phrase blow a fuse. You can even put in a dollar bill if you want to. There's all kinds of things that you can play with here, and the list even goes on. So and there's a dog. That's my favorite one. So please, I would encourage you to kind of play around with this. As you finish going through the Pear Deck, you'll be prompted to draw a picture of what you built. And there's also space for you in the student notebook to draw pictures of what you built. So again, please go through the Pear Deck at your own pace and answer the questions. At the very end, I would like for you to summarize. In this space below, write 2 or 3 sentences and draw pictures that summarize everything that you learned in the Pear Deck. I would hope that this lesson is engaging to you and that you enjoy going through the Pear Deck. On Friday, we will come back together to do a Legends of Learning playlist and to do a quizzes to review everything that you've learned this week. I'll see you later.